Okay, let's continue, and we are actually have to resume under discussion of the material facts of steel. So we are on the number 5. So China is the first country to produce more than 200 million tons of good steel. So that is a necessary element for them to be able to become the second largest economy in the world. Okay? So after just 7 years, so after producing 200 million tons in 7 years, they become the second. Only 7 years. So 20 years ago, 30 years ago, China is one of the poorest country in the world. Okay? Our country is better off than China. But look at China nowadays. Okay? So China is the world's largest consumer of steel, using it in cars, general industry, construction, and so on. Almost every industrial application. The United States and China are the largest importers of steel. Take note, they are producing 200 billion tons of steel, but they still import steel. They are still importing because of rapid development of Chinese industry. Okay? Rapid development. In 7 years, take note, they have the technology to be able to put up a 1,000 bed capacity hospital in 1 week. Okay? 1,000. Okay? Our own cities or our local hospital in the city is less than 1,000 beds, about 300 beds capacity. And it was constructed 10 years. Okay. Little by little, it was constructed. But they can do it in 1 week. Okay. Use of steel and prefabricated concrete. Okay. Japan is the largest exporter of steel. Export. So they do not have too many mining or natural resources, but they buy the raw materials from a small nation like us. They are buying the raw materials, the raw iron, then produce steel with good quality, and then sell it back to us with what? Times 4, times 10, times 4, times 10 of price. Okay. Sometimes times 20 of the price, because almost they buy raw materials if nothing. Okay. Okay, so the price of raw material is really nothing compared to the price if you process this steel. So the main problem in our country is we do not have the capability to process and make a good quality steel. Okay, so we have plants, but very limited. We have very limited steel plants in our country, and we are actually using in one of the plants Indian technology or Australian technology. Okay, but still it's not on the same league, the same quality of those steel being produced in Japan. But they are very expensive. Okay, these are very expensive steel. Steel is the world's most recycled material. Note, that is a good part for steel. Okay, there's no actually wastage. All the extra chips, waste could be recycled and reused and remelt and reproduced into a new steel material. Okay? Steel is recycled mostly from junk cars. 300 to 400 1,000 cars per year per steel mill. Can you see that? Junk cars from around the world is being shipped back to Japan in order to be recycled. Okay, 27 cars per minute in North America. Okay, so if you divide it, how much is 400? So 400 is about 365. So 365. So meaning to say 1,000 per day. 1,000 car per day. So just imagine 1,000 divided by 25/4. So that is what? 40, no? 40. Okay. So that's how they recycle cars. No? 27 cars per minute in North America, meaning US and Canada. Those are North America. More than 60% of steel produced annually is from recycled steel. Take note, 60%. They are just recycling it. Okay. Properties. That's why you can see in our country there are what? Scrap shop. Okay. There are scrap shop and buying what? Old equipment with the steel parts. Then they will become what? Per kilo, 4 kilo. Okay. Properties of steel are not altered by how many times it is recycled. Per pound of material, steel is the most efficient of all building materials. A small amount of steel can do load-carrying tasks with a fraction of the material needed for other materials such as concrete or wood. Take note, actually, later on we will study in reinforced concrete. How many percent is the steel reinforcement in a concrete? Very little. I will tell you later. Okay? Very little. So steel is the densest of structural material and therefore handles longer span and produces lighter structure with the greatest economy. That's why they can be used in long span, light weight, therefore can be used in high-rise building. Steel can be found in fasteners, meaning nails, bolts, pins, rivets. Okay, those are fasteners. Structural components, rebars, sheet metal, appliances, cars, and ships. Okay. So let's take a look deeper into what we call steel. Steel is an alloy of iron and carbon. That is actually the main ingredient. That's why it is called steel, iron and carbon. But carbon is actually expected to be less than 2%. If you put more carbon, the steel, the quality or the strength of the characteristic of the steel will deteriorate. That's why it must be limited less than 2%, actually less than 1%. I think about 0.2% to 1%. That is the target with the best quality. And manganese. Manganese is just another form of metal, an element which consists less than 1%. Okay? It also contains small amounts of phosphorus, silicon, of course, sulfur, and oxygen, of course. Very small amount. Manganese, carbon, and iron are the top three. Okay? What can we say about carbon steel? One type of steel, carbon steel. These chemical elements are controlled to provide consistent quality and grade of steel. So stable quality you can make the same quality over and over again. And that is the beauty. You cannot do it with what? Wood. If you plant the tree, after 10 years, the quality of the wood is different from 20 years ago. Okay? However, still, same. What can you say about the quality of concrete? Depends on what? On the workers. The worker who is actually mixing, the worker who is actually doing the or using the concrete or wet concrete. Okay. Carbon content greatly affects the properties of steel. Carbon content. That's what I said a while ago. There are percentages of carbon which greatly affect the quality. If you put less than 0.2, less than 0.1% of steel, you will have what? Deteriorating quality of steel. Okay. And more carbon increases, okay, strength, hardness, corrosion resistance. More carbon decreases malleability, ductility, and weldability. So almost what? Opposite, no? Strength, malleability. Hardness, ductility. Corrosion resistance, weldability. Okay? They are related oppositely. Okay? So that's why if you add more carbon, so for example, 0.1, you already have 0.1% carbon. If you add more carbon, your steel will become stronger, harder, and have a good corrosion resistant property. Up to a certain optimum, then the quality is again going down and still acceptable up to 2%. Okay, but acceptable less than 2%, but 2% and above content of carbon is not a good quality for steel. The amount of carbon does not affect the modulus of elasticity, okay, of the steel. The same modulus of elasticity, but the strength, hardness, corrosion resistance, malleability, ductility, weldability will change. Okay. Next type is what we call alloy steel. Alloy steel is carbon steel to which one or more chemical elements have been added to achieve physical or chemical properties desired. Okay? So, for example, what is the most popular alloy steel? Stainless steel, the most popular one. By adding what? Chromium and nickel. Okay? By adding chromium and nickel, we have the most popular type, which is stainless steel. Corrosion resistant property because of that. Okay? But usually we are not using that as a structural, as a natural structural element. We can, but we are not. Because some carbon steel, which are not alloy, okay, so have a better strength quality, hardness quality, but all those that do not have a good corrosion resistance quality. But by what? By maintenance, continuous what? Checking, painting, okay? That's how they control the corrosion resistance, okay? Application of chemical, okay? So weathering steel, another alloy, another type, weathering steel. 410 steel, adding copper, phosphorus creates steel. So copper and phosphorus is added. Stainless steel, chromium and nickel. So take note of that. Additional of chromium and nickel become stainless, and addition of copper and phosphorus become weathering steel. Create a steel that forms an oxide coating rust that adheres to the base metal and prevents further corrosion. So this is what the first pillar in India is made of. Okay, it is Corten steel. So it is an alloy of carbon steel and copper plus phosphorus. Look at the color. It is reddish color because of what? Of rust. All of these are rust, but only at the surface. Internally, there is no rust internally because it prevents the rusting on the surface will prevent further corrosion. That is the beauty of this. No? This is a Corten steel structure. Okay. I think in Texas, no? In Texas, fully corroded, but it can withstand centuries because there will no further corrosion. Okay. Similar to the first pillar in India. Okay. So much deeper look into the chemical component or composition of steel. We have what? Steel, wrought iron, and cast iron. So as I said a while ago, slides ago, we have wrought iron. What do you mean by wrought iron? There is 0.2% or less carbon. Less than 0.2% carbon. Okay? So if we have 0.2% up to 2%, that is what we call steel. Take note. Small amount of carbon, wrought iron. 0.2 to 2% steel. And 3 to 4% carbon. Okay. So more carbon content. So it will become what? Cast iron. And take a look at the what characteristic. Soft and malleable. If you want soft and malleable piece of metal, you need wrought iron. Wrought iron is the type of metal used in what? Fence. As you can see, there are what? Decoration. There are several decoration, no? That make up the fence or what? Fence or so those decoration, they can easily what? Bend and form it into a decorative shape, size. No? It is easily done because it is soft and malleable. Okay, that is wrought iron. How about cast iron? If you do it with the cast iron, this is brittle. Brittle meaning it is glass-like. It could easily be damaged. It could easily crack. Okay, so that is what we mean by brittle. Much like a glass-like characteristic. Brittle. So it is very hard. Of course, it is harder than steel, but also brittle, and we do not want that. Okay, in our structural study. Okay. Okay. So controlled amount of manganese, phosphorus, silicon, sulfur, oxygen, then you have what? Carbon steel. Okay. If you control these things in terms of percentages, okay. If you control this, less than all of this, total less than 1%. So you have carbon steel. So then we have again plenty of types of carbon steel. Okay, we have mild steel, medium steel, hard steel, and spring steel. Okay, spring steel is just like tool steel. Spring steel has a very good strength and ductile characteristic, balance between those. No? It is ductile, but still strong. No? So mild steel, 0.2 to 0.25% carbon. 0.2 to 0.25, mild. 0.25 to 0.45, that is medium. Okay, take note of these things. This is very specific. This is a very specific definition of different types of steel. What is hard steel? 0.45 to 0.85 carbon. What is spring steel? 0.85 to 1.85 carbon. That is spring steel. So 0.85. So if you add combination of chromium, cobalt, copper, molybdenum, nickel, tungsten, and vanadium, we have alloy steel, different types of alloy steel, like stainless steel and weathering steel, or corten steel. Okay, so this is a very good graphical representation of different types of steel. So we are going to use this one. This one. Medium steel and hard steel. So this one, okay. So production of steel, iron ore are being mined as natural resources, and it constitutes 5% of Earth's crust. 5% in Earth's surface is iron. So 70% of Earth's core is iron. So meaning to say, you need to go down and dig a hole nearer and nearer to the Earth's core. Earth's core meaning center of the core. So the middle of the Earth. So 70% iron is there. So US has roughly 25% of world coal supply. Steel is heated to molten state to remove oxide. So to release oxides. Okay. 3 types of production furnaces. So because oxide is the element that reacts negatively with almost everything. Oxygen, if it reacts, it will become what? Rust. Okay. So almost. So 3 types of production. We have open hearth furnace, basic oxygen furnace, electric arc furnace. Whether BOF or EAF. So this one, basic oxygen and electric arc. I think nowadays OHF or open hearth furnace is now what it's not available currently due to what global warming restriction. Okay. So although basic oxygen furnace has a lower percent of recycled steel, it is still as environmentally friendly. Refining is the addition of alloys to obtain certain characteristics in steel, like molybdenum. The result will become stronger. Manganese, resistance to abrasion and impact. Okay? Abrasion, scratches, no? And impact. Okay? Vanadium, it will add strength and toughness. Okay? Nickel and chromium. Take note, strength and toughness. Toughness, very hard to crack it. No? Nickel and chromium, toughness, stiffness, and corrosion resistance. That's why this what? For what? Stainless, no? Or stainless. Toughness, stiffness, and corrosion. But not strength, no? Toughness. Okay? It's very hard. I use stainless steel in fabrication, in machining. Very hard. It's very hard. In our local dialect, makunat. Napakakunat ng stainless. Okay? So, napakahirap i-machine. Okay? So, but we have different techniques nowadays, plenty of techniques in order to handle stainless. Electric arc furnace process is environmentally safer than any of the three. Okay? Casting liquid steel is cast into semi-finished products, what we call billets and blooms. So smaller solid pieces, small solid pieces called billet and bloom. In 1980s, computer controls were prevalent in steel mills. So we are the basic type of mill, hot rolled mill and cold rolled mill. So the type of process in making the steel. Okay, so that is what we call hot and cold. Okay. So hot rolling. Before hot rolling, slabs, blooms, and billets are heated in a furnace to about 1200 degrees Celsius. Take note. Okay. So melting, no? Okay, almost melting. No? Actually, this makes it easier to roll the steel and remove the rough, flaky surface on scale. Okay, so what about cold rolling? Certain types of steel are also cold rolled after hot rolling. Okay, before cold rolling, the steel is cleaned with acid chemical to remove the scale. Okay, so we need to remove the scale. Cold rolling is carried out at room temperature and is rolled at very fast speeds using lubricants to reduce friction. Cold rolling increases strength. Okay, so cold rolling is compressing it compresses the steel material to form the desired shape and size. Makes steel thinner and produces a bright, smooth surface. Okay? So those are the good characteristics of cold rolling. So if your steel plant is cold rolled, meaning it doesn't have the hot rolling mill, so it will buy the hot rolled products and then use that to cold roll the steel. So a complete process could be what? Making the blooms, billets, then hot roll, then cold roll. So that is the complete steel process. And under the three steel sub-plant, that is actually steel plant. There are steel plant that make billets, blooms, and slab. Another plant for hot roll. Another. Why? Because these are big plants. One hot rolling plant is very big, no? One hot rolling plant is very big plant. About the size of MOA. Okay? That is one hot roll plant. And another cold roll plant, almost the same size. So very big. And another for much bigger blooms, billets making. So very big plant. Okay. So I am employed by the Philippine Steel before, and our main plant, the biggest plant is in Balayan, Batangas, and very big area, very big steel plant. That is what partial. There is a what preparatory hot rolling section that is not complete, but in order to make the output thinner, because because the field steel's product are what? Thin product, flat product, okay? Not long products. Flat product meaning what? Decking, roofing, and so on. So those types of products, okay? Then before cold rolling, the cold rolling plant is complete. And after the cold rolling, and then the product processing, okay? Making the corrugated products, making the baking, shapes. So there is a complete set of what lines and very long. There's a very long lines. Okay. So that's all for this discussion. We have another challenge question. For this video, please answer the following material question. So question number 33, what is the standard height of reflectorized thermoplastic rumble strip? This is rumble, not rubble. Okay? This is what? Typo error, rumble strip. We call this as rumble strip. Okay? Rumble strip. If you take a closer look, it looks like this. That's why if the vehicle pass over this rumble strip, what happened? So that's what will happen. Grrr. So that is what is to be expected. Why? There is a purpose for that. This is under traffic engineering actually, but still as an additional challenge problem. As I explained before, we have, okay, so letter A, 4 to 13 mm. Letter B, what is this? I have what? Race. Okay. Sorry about that. We have what? Letter A, 4 to 13 mm. Letter B, 5 to 13 mm. Letter C, 3.2 to 4.8 mm. And letter D, 2.2 to 4.8 mm. So the height, we are talking about the height of the rumble strip. Okay. So, thank you about that. Again, this is Dr. EYPEI, Preaching Engineering for Nation.